Hi everyone. So we will be discussing some major topics in networking, wireless networking during this video session. So to start with, if I give a brief introduction, as you can see my screen, I have opened a introduction in a research paper. Right? So now in today's world, the network that we have built are so immense, so advanced, and they are built using, most of the time they are built using wireless network technology, right? And for the start, the major part that we have to discuss about this is the ISO-SI model, open systems interconnected model, that drives the network communication. So it is the main backbone like structure of all the network, right? So here we are talking about 7 layers. Then after that we have the uh, modes of data transmission, TCP, UDP, right? Then how the data packets are transferred. Then some other major topics that we will be discussing during this whole video session are wireless signal, about the wireless signals, antennas, then decibel calculation, signal strength, bandwidth, everything. All those topics will be discussed. So to start with the ISO-SI framework, there are 7 layers in this, starting from the application layer, that is the topmost layer, the layer 7, then presentation layer, then you have the session layer, transport layer, network, data link, physical, right? Which is the lowest layer, layer 1, right? That deals with all the network devices, the physical devices. It is the physical part of this. Then in the first 2-3 sessions, like we will be discussing about these the layers, then the TCP/IP protocol suite, right? That means the protocols, the key protocols in data transmission, TCP and UDP, transmission control protocol, and UDP user datagram protocol. So if I give a brief introduction about these layers, the topmost layer, the application layer, it is the layer which is responsible. That means all the application level softwares are dealing here, the high level protocols, right? Some major protocols that we are using here is S.L.D.P, simple mail transfer protocol, FTP, file transfer protocol, then HTTP, right, hypertext transfer protocol. Then these are some major protocols here. Then we have the presentation layer, which is responsible for the data translation and encryption, right? It is the mediator between network and application, right? So some major protocols that deals here are JPEG, MPEG, EDC, DIC. These are some major protocols. Then when we go further down, we have the session layer, which is the layer 5, responsible for managing, controlling dialogue. That means the sessions between two devices, right? Some protocols are RPC, PPTP, STP. The next layer, the layer 4, transport layer. This ensures the reliable data transfer. That means reliable data transfer between systems. Mainly error detection and error correction is the major task of this layer. Then the next one, network layer, which handles the routing, forwarding, everything. Some major protocols that runs here, ICMP, BGP. Then data link layer, we have the layer 2, right? This is also like handles the error detection, correction, everything. So MAC, Ethernet, these are some protocols that deals here. Then we have the physical layer, the lowest layer, responsible for transmitting raw bit streams or physical media like cables, radio waves. It can be either guided or unguided media. Next, here we will be discussing the TCP/IP protocol suite. Now, TCP/IP is like we call it is the fundamental, like the main part which ensures reliable connection between two users or two machines in a network. Where there are it uses two protocols, UDP and TCP. UDP, user datagram protocol, which is less reliable. Then we have TCP/IP, transmission control protocol, internet protocol, which is the most reliable one, right? That we are using nowadays, right? So after we like the other parts, if we talk about that, I have added in the document, right? Then some other parts that we had to discuss were some the parts like the MAC address, error correction, flow control, then some of the signal characteristics of the data and signals, then impairments caused in signals, right? So the error correction and error detection. Now, if we talk about that, right, there can be errors in the PDUs, the data packets that we send, right? To detect that error and to correct that error. So there are some methods that they have introduced in these in order to detect as well as to correct, right? Then next, if we talk about the signal, the data and signal are the most common methods of transferring. The two most common methods of transferring signals are either analog or digital, right? So mainly the strength of the signal, like we can say that it depends on the amplitude of the signal, the amplitude of the wave, right? Then the frequency, if we talk about the other part, which is frequency, right? It is the complete cycles it completes in 1 second, number of complete cycles in 1 second, that is measured in hertz, right? High frequency is used in low distance area connection. Low frequency is used in higher distance connection. That means, like, if you take radio signals which have a low frequency, like they travel a high distance. If you take about the low frequency signals, it travels for a less distance, right? Then some impairments caused in signals are attenuation that we have discussed, then distortion, noise, right? Those are the things, right? So that means mainly attenuation is loss of energy of the signal. It can be either as heat, right? Some other methods, right? The data, some data might be lost, the signal strength might be lost as heat. Then distortion means the signal changes into another shape, right? Then because it can occur when composite signals, like they right, when they meet, because the signals are made from different frequencies, this distortion happens. Then the other one is noise, right? The other types of signals describe the original signal. Those are some characteristics of signals, the impairments caused in signals that we can talk in signal and data and signal. Then we will be moving on to the decibel calculations. Decibel, what is a decibel? How to calculate a decibel, right? So if we talk about decibel, it is a logarithmic unit used to express the ratio of two values of a power or a signal level. It is the power of the signal, how much power this signal has, the strength of this signal, right? Now decibel is the unit that we are using. It can be the formula. The formula that we are using to calculate is 10 log base 10 P1 into P2, right? Where P1 and P2 are the power levels, right? Power levels that we are compared, right? Also we can use to calculate, also we can use either power of the signal or the voltage. Well, then we are using 20 log 10 base voltage 1 and voltage 2, right? Where V1 and V2 are two voltage levels, as you can see I have included in here, right? So these are the calculation of the decibel. Then some other key properties of decibel are the The next part, some of the key properties in decibels. That means some of the key properties here, right? Mainly amplifier gain. That means a measure of amplifier ability. That means the waves ability, the signal's ability to increase the power. That means increasing the amplitude, right? That is a key property here, right? Then the amplitude or the signal strength depends on this amplitude, right? The amplifier gain, the strength of the signal, right? Higher amplitude, higher the signal level strength. Lower amplitude, that means the signal level is low, right? So here in signal transmission, right, this amplitude, the signal strength is a major component, right? Then we are coming to analog versus digital signal. Now analog, it is a continuous signals that can vary smooth over a given range, right? Digital are discrete signals that can take on a finite number of values. Digital means zeros and ones. Analog means it can vary, right? Voltage levels can vary in analog signal. Digital means 0 and 1, power on and off, right? Then bandwidth, right? Here at a given time, at a given point, number of data. So we can say the data amount of data that can pass through a certain point in a given time, band, right? So higher bandwidth means higher number of data, lower means low number of data, right? So here some signal transmission modes we are talking. Mainly we have wireless or wired, guided or unguided we are calling it. Then we have guided, twisted, pair coaxial cables. Then fiber optics, unguided media, we have infrared, radio waves, microwaves. So those are unguided media and guided media. Then the mainly unguided media are directed through antennas, cell towers. So we will be talking in the next session, right? Then here mainly we are talking about the decibels and decibel calculation, signal strength, power of the signal, how we can lose power of a signal, how we can gain power of signal, right? The calculation, right? Okay. Then the next part, sampling. It is the first step in converting analog into a digital, right? Right. So in order to communicate, sometimes we need to convert analog signals into digital, digital into analog, both way, vice versa, right? So the first step in that is the sampling, right? Okay. Then we will be going to the pulse code modulation, PCM, right? Next we will be discussing is the PCM, or the pulse code modulation. This is a technique of converting analog signals into, such as sound or voltage, into digital signals, analog into digital. There are key steps in converting an analog into digital. The first one is sampling, right? Okay. Then we have the next step, which is called quantizing, encoding, right? So these are the steps in converting a analog into a digital, right? In the first most one is the sampling. Then we are moving to quantizing, right? Now when the signal has been sampled, right, the next is quantizing, which involves in mapping the continuous amplitude values of samples to a finite set of discrete, the continuous set into a discrete set, right? Finite set, continuous into finite set. Then the next part is the encoding. Encoding means here we are each quantized quantized sample, right, is converted into a binary code. It is converted into a binary code in encoding, right? Then we can convert that means the digital conversion, right? Binary coding means, encoding means converting into digital, right? Then in here we are talking of a modulation technique, right? That means this technique is essential for transmitting signals over long distance, right? Mainly in wireless communication. So why modulation is required? Mainly reduce the interference, reduce the antenna size, right? Modulation helps in reducing the size of the antenna, then reduce the interference, right? Interference means with multiple signals, right? Right. Then there are two types of modulation, analog and digital. In analog we have amplitude modulation, frequency modulation, phase modulation, right? Right. Then in digital modulation we have amplitude shift keying, then phase shift keying, frequency shift keying, right? Then both modulation and PCM are some fundamental techniques in modern communication, right? So these are some fundamental techniques, right, that we need in modern wireless communication, right? Okay, moving with the next part, it is multiplexing. Now multiplexing is a technique that combines multiple signal into signal transmission. That means when we transmit data signals or any signal, right, multiple signals we can transmit using a single transmission medium or a single channel, right? Then this part that we are discussing, this focuses on, right, some multiplexing techniques, right? First one is time division multiplexing, we call it TDM. Then statistical TDM, and frequency division multiplexing, FDM, right? So TDM, like multiple TDM means that time division multiplexing. It is a technique where multiple user signals are transmitted over a single channel by dividing the available time into fixed intervals. Means we are dividing the available time into fixed intervals and we are transmitting over a single channel. Statistical division means, right? Statistical time division means, right? We are allocating dynamically. We are allocating the time slot, right, based on the user's need. Dynamically we are allocating based on the user's need. Then we have the frequency division multiplexing, FDM, right? That divides the available bandwidth of a communication into non-overlapping frequency. We are dividing the available bandwidth into non-overlapping frequency, right? So these are some techniques. The next most advanced technique is the orthogonal frequency division multiplexing, we call OFDM, right? This is advanced than FDM, normal frequency, our traditional one, frequency division multiplexing, right? So here we are discussing some differences, then the benefits, right? We are focused on that. Then the next part is a demultiplexing. Now when we send and multiplex, that means several signals over single channel, then we should be able to get it into a signal transmission, single transmission, right? So that is demultiplexing, right? That part is also done here in multiplexing technique, right? Then the antenna, the device that we are using in signal transmission, the antenna, the primary main function of an antenna is to facilitate the transmission, right? Transmission and reception, transmitting and receiving electromagnetic waves. That is the purpose of an antenna, the function, right? Mainly electromagnetic and other waves, the types of microwaves, radio waves, right? Those are the waves that we are using in antenna connections, right? Then here we have types of antenna, the dipole antenna and the, yeah, then some fields in antenna design, E field and H field, right? These are some fundamentals. That means the H and E fields are some fundamentals in functioning of antenna, right? They are needed in functioning of antenna, right? So E field is, so E field and H field are some fundamental functionings in antennas. So E field is created due to the voltage wave, and H field is created by the alternating current and fluctuates the electron flow. Then some antenna parameters in antenna and applications are, right? So in the parameters that influence in antennas are performance side are polarization, feed impedance, gain and directivity, resonance and bandwidth. So these are some parameters influencing antenna performance, right? So these properties make antenna essential for applications in mobile communication, television broadcasting, Wi-Fi routers, and many other wireless technologies. So the antennas have become a major transmission mode, major device in order to transmit and receive signals, either electromagnetic or any other signal in wireless communication, right? Next, we are coming to cellular network systems and cell towers. Now we are living in a wireless era, right? Everything, connections, communications are done to mobile phones, cell phones, right? So these cell towers, right, facilitate the communication between these mobile phones, right? Mainly so the signal modes that we have now, 2G, 3G, 4G, 5G, right? So these are some improvements over wireless communication, right? So if we come here, 5G technology and smart cells, right? So it has made some improvements in the latency, that means the speed, the capacity, right? Capacity size high, speed is high, right? So these are some improvements, right? Then another major topic here is MIMO, multiple input, multiple output MIMO, and beamforming, right? Beamforming where it means a technique that directs the signal towards specific user, enhances signal strength and reducing the interference, right? Right. Both MIMO and beamforming are integral to the success of modern communication, right? So these two key points are the main success in modern communication, right? So due to this growing Wi-Fi traffic challenges, some challenges due to these are limitations, like now mainly the collisions that occur in the signals, right? These are the main challenges due to this growing traffic, right? So traditional Wi-Fi antennas, traditional towers, those are not usable due to this high demand, high traffic generation, right? So here we have come to smart antenna technology, right? This reduce interference, faster performance, right? Improve consistency. These have these advantages. Then uh, the duplexing in LTE, right? Duplexing, this refers to the method of allowing two-way communication. Now, when we talk about the modes, transmission modes, for full duplex, duplex, half means in one direction, but not at the same time, not simultaneous. That is half duplex. Walkie talkie. Full duplex means both directions simultaneously. Mobile phone, right? Those things. Then frequency division duplexing. This separates the frequencies transmitting and receiving, right? This separates the frequency. That is frequency division duplexing, right? So, and the next one is TDD, time division duplex, right? Same frequency for both transmit and receive. This uses the same frequency for both transmitting and receiving, right? So this is very cost effective, right? Then some factors affecting duplexing are latency, equipment cost, then distance consideration, right? Traffic volume, right? These are some factors affecting the duplex. Then when we come to the multiple access techniques in telecommunication, multiple access techniques, multiplexing and multiple access are some fundamental, right? Multiplexing means many signals over single channel, right? Then here we are going to talk about the multiple access, right? So some multiple access technologies, right? Are in networks are CSMA, we call carrier sense multiple access, right? Then CSMA with we have CSMA with collision detection, then CSMA with collision avoidance. Okay, so these are some data transmission ways, right, modes, right. So if we talk about the CSMA, right, in multiple access, right, this is used to manage data transmission in shared networks, right. It works by allowing devices to send medium before transmit, right. So here with collision detection, right, here if a collision is detected, transmission is aborted, so it is not done, the transmission is not done, it is aborted. But in collision avoidance, the next one, CCMA collision avoidance, right, it transmits the data, right. If a collision is detected, it back off for some random time. Once the channel becomes clear, it resends the transmits the data, right. So these are some multiple access technologies in network. So next we will be discussing about the problems that we have here in wireless network transmission, right. The first one is the hidden terminal problem, right, where two nodes cannot identify each other, right, detect the collision, right, they are hidden from each other, right. So to overcome this, they have an algorithm, MACA algorithm, multiple access control avoidance algorithm, right. This uses two frames called RTS and CTS in order to prevent this terminal problem. That means these two frames coordinate transmission between nodes, right, each and every from private to node. So this hidden terminal problem eradicates due to this MACA algorithm. So the next one is exposed terminal problem, where the node incorrectly assumes that it cannot transmit data because it can hear another node's communication, right. So due to that, it occurs the exposed terminal problem. So as the solution to this exposed terminal problem, also they have the MACA algorithm, right, introduced. And when we go further, we have some standards defined by IEEE. It calls the 8 node to 11 family, right, 8 node to 11, 8 node to 11A, 11B, right? These are some standards defined by the IEEE for this data transmission wireless network communications, right. Then going further, we are coming to the availability of the channels, the global differences between these channels, right. Then dynamic frequency selection channels, right, Wi-Fi LAN types, right. Then mainly the next part is the security part, the types of attacks that we can have: active attacks, social engineering, phishing, session hijacking, right, tracking, or insider attacks. So these are some attacks that can occur. So in order to overcome these attacks, they have some security features: SSID, LAN, MAC address filtering. So these are some security features introduced, right. Web, then WAP, wired equivalent privacy, WPA, WPA2, AES encryption, right. Then the main goals of security is to authentication and encryption, right. So some tools for security in a wireless networks are MAC filtering, geofencing, WAP, wired equivalent privacy, open authentication, like shared authentication, right. So these are some security concerns that we have to consider when in a wireless network connection, right. The security improvements over web, TKIP, right, temporal key integrity protocols. These are some protocols used. Message integrity check, MIC, right. So discussing all these security aspects, the session comes to the end. So finally, as the conclusion, we can say that we have talked about the 7 layers, then the decibel calculations, decibel, what is a decibel, decibel calculation, then multiplexing, PCM, right, converting digital to analog, sorry, analog to digital, right, then antennas, cellular towers, right, all these points are added in this particular document. Then also the other parts that we have discussed are the problems that can occur, the solutions, then some protocols that we are using, right. Then finally called the security aspect, right? Finally, security aspects. What we secure, how we secure, right? Then, so these are the parts that we have added. I have added in this particular document, and also the references are added here, right? The places which I have taken all this information, right? So with all that, I wind up my video. Explains the wireless network technologies, basics, advanced topics, some advanced topics, and security aspects. So thank you all for